Hey everyone, and welcome back. I thought I was recording for the entirety, but I guess not. So we're going to be having part 2 of evaluating trig functions using function notation. In the last video, we did sine and cosecant, and now we're just going to do a couple more examples. So thanks for sticking around. Thanks for watching part 2. Part 2 is honestly where things get a little more complicated and things that you're going to want to pay the most attention to, but part 1 was necessary so that we knew how to evaluate trig functions just in general. So let's hop straight into it, shall we? So now we're going to be evaluating the function h of x. For the following, h of x is defined to be cosine of x. And we still want to find h of 0, h of pi over 2, h of pi, h of 3 pi over 2, and h of 2 pi. So first things first is we are going to want to draw a quick little visual for us just to help us remember what we're dealing with here, our units of measure, things like that. Draw and sketch a little unit circle. Right, here we go. This point over here is 1, 0. This point over here is 0, 1, because x has no height or no distance, but y has some height. This one we're moving in the negative direction. So x is -1, y is 0. And down here we have 0, but y is -1. And at each of them, this over here is 0 and 2 pi. Moving around. Oops. Let me make sure I'm sharing the correct screen. Hold on. Yep. Moving around our unit circle up at the top, between quadrant 1 and quadrant 2, that's pi over 2. Pi is, oops, right here. Then we have 3 pi over 2 down in between quadrants 3 and 4. So again, we still want to evaluate h of 0, h of pi over 2, h of pi, h of 3 pi over 2, and h of 2 pi. So h of 0 is basically asking, if the input is 0, what's the output? So what is the output of cosine of 0? And remember, x is cosine, y is sine. So we're going to look at the y coordinate, or the x coordinate. I apologize, x coordinate. So cosine of 0 is 1. This becomes cosine of pi over 2 for our second one. So what is the x value at pi over 2? That's 0. What is cosine of pi? What is the x coordinate? That's -1. What is cosine of 3 pi over 2? The x coordinate is 0. And h of 2 pi just really means find cosine of 2 pi. And if we look at 2 pi, that's right where we started a whole rotation, cosine is 1. And really, if we think about this, this makes sense, because if we have a graph, right, let's call this first tick mark here pi over 2. Let's call this one pi. Let's call this next one 3 pi over 2. And this last one 2 pi. Really, what we're saying is when x is 0, the height is 1. So when x is 0, which is right here, the height is 1. When we input 0, our output is 1. When our input is pi over 2, so right here at pi over 2 along that region right there, the height is the output, which is 0. So our height's at 0. At pi, when x is pi, our output is at -1. At 3 pi over 2, our output is at 0. And at 2 pi, our output is back at 1. And we can see from these dots that, yeah, this is exactly how we graphed cosine. And that makes sense, that literally we're just asking is when the input is a certain value, when it's 0. what is the corresponding output? When the input is pi over 2, what is the corresponding output? So really, it's just helping us plot these points along our graph. And we could do values in between too. Say if I wanted to find h of pi over 4, right? Pi over 4 is halfway. So we want to know when h is pi over 4, what's that height right there? And we know pi over 4 is 45 degrees, and both coordinates are root 2 over 2. So root 2 over 2 would have been that output, root 2 over 2. So really just asking when x is inputted, what's the output? Let's do a few more examples, shall we? So let's up the ante here. Let's make it a little bit more difficult. And let's do still cosine, but let's make our function cosine of x minus pi, x minus pi. And we might be able to make a few assessments about this, just based on what we know about our function. We might notice that if we have x minus pi, that really means that we're shifting our graph right pi units. But that doesn't really help us with the evaluating. It might help us looking at the graph, but that's not what we're asking here. We're still asking us to find the value of our function. So remember, the value where k of x is given, right? K of x is equal to cosine of x minus pi. When we're asked to evaluate something, really, all we want to do is plug in these values for x into our original function, into k of x, which is defined above as cosine of x minus pi. So let's do it. K of 0 is going to give us cosine of 0 minus pi. And that gives us cosine of negative pi. Now, how is a negative radian measured? Just move this over a little bit, pi. A negative radian just means in the opposite direction. So generally speaking, when we have our unit circle, it goes counterclockwise, right? From this direction, that is a regular positive value. Positive radians, positive degrees. However, if we switch it up, if we start here and go the opposite direction, that's going to be a negative angle value. So normally, positive pi is over here, right? That's positive pi. That's going in this direction. But if we go negative pi, still starting here, and then we end up in the same spot. Okay, so negative pi is still the same spot. The coordinate for that is -1, 0. So cosine of negative pi is -1. Let's do the next example. Cosine of pi over 2 minus pi. So we're going to need to get a common denominator. Since this one already has 2 on the denominator, let's do that. Cosine of pi over 2 minus 2 pi over 2. It's the same thing. Multiply pi by 2 over 2. And we get pi minus 2 pi gives us cosine of negative pi over 2. Again, that's just going to be an angle in the negative direction. So pi over 2 is going to be right down here, negative pi over 2. And the coordinate there is 0, -1. So cosine of negative pi over 2 is 0. Let's try pi, k of pi. That's going to be cosine of pi minus pi. And this one's cool because then we just get cosine of 0, which means we don't have neither a positive nor negative rotation. We're just ending up right here on our unit circle at 0 radians. And that coordinate is 1, 0. So cosine of 0 is 1. Continuing on, we have cosine of 3 pi over 2 minus pi. Again, we're going to need a common denominator. So we get cosine of 3 pi over 2 minus 2 pi over 2, leaving us with positive pi over 2. Way back to regular life. Cosine of positive 2 is up here. Ooh, I should not have used pink. Oops, right up here. Pi over 2, x is 0, y is 1. So this is going to be 0. And lastly, k of 2 pi is cosine of 2 pi minus pi. That just gives us the resulting cosine of pi, which is cool. That's regular life. Pi is where it always has been, where it always will be, way over here. That coordinate is -1, 0. So cosine of pi is -1. Pause right now and let me know, what were you afraid of before and what have you learned since we evaluated something that looks kind of crazy? All right, let's do one more set of examples. Kind of the same, slightly different. Our next example will be to evaluate L of x. Our function L of x is defined as cosine of x plus pi over 2. Again, this is just how the function is defined, and we simply want to fill in everywhere there's an x. We want to replace it with our brand new values and see if we input these specific values, what's the output? The first one will give us cosine of 0 plus pi over 2, which really just gives us cosine of pi over 2. Now, I didn't draw out a unit circle, but what is cosine of pi over 2? That's going to be 0. So nice to draw this quick little sketch. Pi over 2 is up here, and that coordinate is 0, 1. Let's do the next one. L of pi over 2 is going to become cosine of pi over 2 plus pi over 2. That gives us cosine of 2 pi over 2, or we can reduce that to just cosine of pi. Cosine of pi is right over here, and that coordinate is -1, 0, so cosine of pi is -1. Let's try L of pi. L of pi is going to become cosine of pi plus pi over 2. And we're going to need a common denominator, so we're going to get cosine of 2 pi over 2 plus pi over 2, which gives us cosine of 3 pi over 2, which is way down here. The coordinate there is 0, -1, so cosine is 0. Ooh, let's see what happens when we evaluate L of 3 pi over 2. Let's see, what's the output value when we input 3 pi over 2 to our L of x function? That gives us cosine of 3 pi over 2 plus one more pi over 2. So 3 pi over 2 plus another pi over 2, add our numerators together, we get cosine of 4 pi over 2. This simplifies to cosine of 2 pi. And cosine of 2 pi is going to be right over here. That coordinate is 1, 0. So cosine of 2 pi is 1. And lastly, L of 2 pi. Cosine of 2 pi plus pi over 2. Getting a common denominator, that would be cosine of 4 pi over 2 plus pi over 2. So that gives us cosine of 5 pi over 2. Our unit circle does not have 5 pi over 2. What are we going to do? Well, let's think back. Okay, notice that we always start at this coordinate here, and we always go counterclockwise. So here's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. So 5 pi over 2 is just one more. Notice we were adding, well, I guess you can't really see the highlighting part there, but we were adding pi over 2 from one whole rotation. So we're just adding another pi over 2. It's still really cosine of pi over 2 is the same thing as 5 pi over 2. So if that's the case, cosine is the x coordinate. So we get 0. Cool. So hopefully, even though these look really scary, hopefully you guys have realized that all we need to do when we're finding out, when we're asked to evaluate, we're just trying to find the value. And all that really needs to occur for us to find that value is to plug in a different value for X based on the ones that they give us. Or I could have also said, maybe I defined L of X to look like this. Actually, instead of calling it L of X, what if I called it L of theta, right? Of cosine of theta plus pi over 2. And I could have said to find theta at 1 pi over 2, 2 pi, 3 pi over 2, just making up random stuff. Like you could just plug in whatever the function was normally defined as. This one was theta, plug in different values based on what it is. It could be theta, it could be X, it could be question mark, it could be anything, but we're really just trying to find the value, the output value when we input a different value. So lastly, it's a little bit of reflection time based on these last 2 videos. Name 3 things you learned and noticed. Name 2 things you were confused about. And lastly, name 1 mistake that you made, because our mistakes are to be celebrated. See ya. Have a great week. Bye.